Am I audible to all of you? Are we live? I think we are live. Yes. Okay. So am I audible? Okay. Okay. Hello to all of you. Please let me know. Am I audible to all of you? First of all, please hit the like button so that I understand that you are listening to me. I am audible. Am I audible? Okay. Hi, sir. Hello, sir. Yes, sir. Yes, yes. I think I am audible. Right? So we are just few days away from the examination. Your first paper is on 25th of April. And today it is 15th of April, right? So we are less than 10 days away from the examination, right? So in a coming time, what we are going to do is we'll try to complete as much as syllabus as possible. So this was a great demand from most of the students. Ki sir, take a quick revision for a circle. So circle can be divided into four parts. This chapter is divided into four sub parts, right? So first part is angle properties of a circle, and the second part, that is part B, is about the cyclic quadrilateral. And part C and D both are related to tangents, right? So what are we going to do today? Mostly today we'll try to cover this A wala part and B wala part. If possible, we'll try to do C and D also, but I don't think so we will be in a position to complete this. If I take this, the class will go on. Let's review our class. Ki what happened? What is the position? By what time we complete these two parts? And if we are in a position, we can start with the next part also, right? So without wasting any time, let us start with this class. Okay. Now you will see that the entire chapter is based upon. Okay, so entire chapter is based upon several theorem. Okay, if you see the syllabus given to us by the council, each and every part have several theorems. To start with, first theorem we have this: the angle that an arc of a circle subtend at the center is double that which it subtend at any point on the remaining part of the circle. And none of the theorem will be asked in the examination with proof. They will not ask you to prove any of the theorem. Okay, so only you have to understand a theory part. Now talking about the proof of this theorem, if you want the proof of this theorem, I already have posted a video related to proofs. Okay, so we can go over here, right? This is my playlist for mathematics on my YouTube channel. You can go to a playlist wala section, okay, and in playlist you can come to mathematics. So these are my videos related to maths, and you will see that this circle wale theorems I have covered, okay, in great detail, okay. So see here in this part, okay, I have covered this theorem, circle theorems, right? So here, then this. Okay, so there are totally 1, 2, 3, 4, 5, and 6 videos whereby I have covered all the theorems. Please check out this theorem. We will have a brief outlook of this theorem as of now. Okay, and I'll just explain. It's not that I'm not going to take this theorem. I'll be taking this theorem, but I'll just give you a brief idea, right? If you want to learn this theorems in detail, you can follow my videos, right? You can go to my YouTube channel, you can go to my playlist, and in playlist in mathematics section you will get all the 6 video related to theorem, so you can go through that. Okay, as of now we will see what this theorem tells us, and then this in this part there are how many theorems? There are about 3 theorems. Okay, and after this three theorems. We are going to solve questions related to this three theorems. So first, let us have the overlook of these three theorems. So, as we all know, name of the chapter is circle, right? So there are two angles in this circle. Please concentrate on two angles. First, angle number one is angle AOB, right? And second wala angle is angle ACB. Okay, can you tell me what is angle AOB called and what is angle ACB called? Okay, if you locate this angle AOB, vertex of the angle is O, that lies on the center of the circle. Okay, vertex of the angle AOB lies on the center of the circle, whereas vertex of angle ACB lies on the circle, or we can say it lies on the circumference of a circle. Can you tell me what these angles are called? Okay, let me check the comments. Okay, yes sir, those videos are helpful. मैंने सब videos देखा है sir. Okay, now these are two angles which you have to concentrate on as far as this theorem is concerned. Now this angle AOB, whose vertex lies on the center, is called the central angle. Please remember this name because we are going to use this name again and again. Angle whose vertex lie on the center is called the central angle, and angle whose vertex lies on the circumcircle, okay, or on the circle, that angle is called the inscribed angle. Okay, this name inscribed angle is not given in all the books given, okay, subscribe to us by council, by CISCE, okay, but this angle, its name is inscribed angle. This theorem talks about the relation between the central angle and the inscribed angle. Okay, central angle and the inscribed angle. And what is that relation? So relation is that ki whatever is the measurement, okay, if x is the measurement of the inscribed angle, if x is the measurement of the angle whose vertex is on the circle, so measure of the central angle, okay, what do we mean by central angle? That angle whose vertex lies on the center. So measure of this central angle is double or twice the measure of the inscribed angle. So this is 2x. So we can clearly see in this diagram that central angle is 2x and inscribed angle is x. Okay, did I made a mistake? Measure of central angle is twice the measure of inscribed angle. Or in other words, measure of inscribed angle is half the measure of the central angle. Please keep this in mind. Okay, please keep this in mind. I'll repeat this once again. Ki measure of the central angle is twice measure of the central angle. You can see here clearly measure of the central angle is twice the measure of the inscribed angle, right? So this is one of the diagrams. So this is the ideal condition whereby you have seen ki how are the inscribed angles and the central angle, how inscribed angle and central angle can lie on the circle. This situation is the ideal situation. Now we will see how these situations can be represented in a different way. So if you see this condition number one, if you see this diagram number one, more or less they are one and the same. See, this angle AOB is a central angle, right? And angle ACB is the inscribed angle, right? Now what we see is that both angles, they are on same side, no problem as such. But if you see this situation, angle ACB, right? Angle ACB is the inscribed angle. Agreed? Inscribed angle. And angle AOB, reflex of angle AOB is the central angle. Okay? Reflex, central angle. Okay? Reflex of angle AOB is your central angle. This angle is the central angle. is the central angle. I hope you are getting it, and I hope you know what reflex angle is. I'm sure you know what reflex angle is, but to refresh your memory, reflex angle is always greater than 180 degree. The angle whose measurement is greater than 180 degree is called the inscribed angle. So even in this situation, okay, measure of the inscribed angle is half the measure of the central angle, or in other words, measure of the central angle is twice the measurement of the inscribed angle. Okay, and one more situation we can take, and one more situation we can have. Let me say we already have discussed this part 1, and this I'll write as part 2. And in this part 3 or case 3, what we see is that this angle in central angle is a straight angle. Okay, it is it this angle is formed. Okay, this angle AOB is exactly equal to 180 degree, is exactly equal to 180 degree, because AB is a diameter of a circle. AB is a diameter of a circle. Let this be the third situation. That doesn't make any difference on our theorem. Measure of the inscribed angle is still half. Half of 180 is 90 degree. So in this case, measure of the inscribed angle will be 90 degree. Are you getting this situation? Are you getting this situation? We'll see all three situations once again. Now, what is this theorem? This theorem says that ki measure of, okay, M stands for measure of central angle. Measure of central angle is twice the measure of the inscribed angle. Is twice the measure of the inscribed angle. Okay, and diagram can be drawn in three cases, right? Let me use some different color. Okay, for central angle we will use this red color. Okay, red color. Angle AOB is a central angle here, and angle AOB is like this. It can be, let us say, it can be acute angle. Yes, it can also be obtuse angle also. Okay, it can be obtuse angle also, but what we see, okay, it is like an acute angle here. This is, okay, or we can say this angle is a is a concave angle. Okay, this angle is a concave angle less than 180 degree. Here angle is exactly 180 degree, means AB is a straight line, and here it is a this angle is a concave angle, and this angle is a convex angle. We can call this as a convex angle also, or we can call this as a reflex angle also. Whatever may be the case, whatever may be the case, result is same. This angle, okay, will, as I told you, we are going to use a different color. So let me use blue wala color, right? So inscribed angle, angle ACB is half. If this is 2x, this angle will be x. If this is 2x, this angle will be x. 2x is equal to 180 degree. So x will be what? Equal to 90 degree. This angle is more than 180 degree. Okay, so you can call this as what? Convex angle. Okay, and this is concave angle. Less than 180 degree, more than 180 degree. This convex angle can also be called as a reflex angle. So in this case also, measure of the central angle, okay, measure of the central angle is twice the measure of the inscribed angle. So if this is 2x, this is going to be x, right? And we will show this reflex angle with the help of the red color, right? So this is first theorem. Okay, I hope you have understood this. If you have understood this, just give a thumbs up or write that in a comment box. Is it fine? Is it fine? Proof if you want. If you want a detailed proof, I have covered that in those videos which I have, which we have seen, which I have shown you in my playlist of mathematics, right? So here we go with this second theorem. The angles in a same segment of a circle are equal, right? And I think the first theorem was there in your 9th standard also, right? Okay, now what do we mean by segment? What do we mean by segment? This is a circle. Okay, this is a circle, this is a center, and if I draw a chord, if I draw this chord, correct, so this part between this chord and this circle, this part is called a segment, and this is called a line segment. Okay, when you draw this is not a segment, but this is a line segment. Line segment. And this theorem is not about line segment. Okay, it is about segment. This part is called segment. Segment is two-dimensional. Segment is what? Two-dimensional. It is a region. It is region between this chord and the circle. Okay, and the circle. If your segment, if this region does not contain the center of the circle, then it is called the minor segment. Otherwise, this region, let me use different color. This region which includes the center of the circle, this region is called the major segment. Major segment. ठीक है? And this is two dimensional, means it is possible to find out the area. Okay, it is possible to find out the area of the segment. So we can say that this segment is two dimensional, whereas line segment, it is not possible to find out the area, but we can find out length. So this is one dimensional segment. Line segment is one dimensional. Okay, so this is a difference. Students most of the time they are confused between line segment and a segment. Correct? So what this theorem is talking about is there are two angles which are in same segment. Let me say I'll use a major segment, बड़ा वाला segment use करता हूं मैं, and look at this angle. The angle which I have drawn using a green color. Okay, I'll call this angle as angle ABC. In which segment do you see this angle? This angle lie in which segment? You can write your comment. Okay, you can write your comment. Is it in major segment or minor segment? Is it in major segment or minor segment? Which segment it lies? Major segment or minor segment? Where? There is a delay in comments. Yes, it lies where in the major segment. We'll take the another angle. We'll take the another angle also in the major segment. And according to this theorem, both the angles are equal. Both the angles are equal. How we can prove this? We can prove this using the previous theorem. Okay, using the previous theorem. Which color should I use? Chalo, let me use a black color. What are we going to do? We are going to consider this central angle AOB. Now, if this central angle is 2x, inscribed angle will be half. So angle ABC is half of angle AOC. So this 2x, so this will be x. And what about angle ADC? Angle ADC is also half of central angle. According to that theorem, कि central angle is twice the inscribed angle, or in other words, inscribed angle is half the central angle. So this is x. Both are half of the same angle, that is a central angle. So both angles are equal. Both angles are equal. This proof I am giving you, but in examination proofs are not required. Proofs are not required. Correct? Let's come here. This we already have seen. Angle in a semicircle. Angle in a semicircle. What is semicircle? Suppose if this is circle and this is center of the circle, and if I draw a diameter, then diameter will divide a circular region in exactly two equal parts. Two equal parts, right? And since this is what? Okay, two equal parts, and each part, okay, each part is what? Semicircle. Half circle means semicircle. Semicircle is also a 2D region. You can find out area. If you want me to shade this, I hope I can shade it. Yes. Okay, this part between a diameter and this circle is a semicircle. Do we have only one? Circle is divided into two halves. So we are going to have, okay, we are going to have two semicircles. Okay, one I am showing with the help of yellow color and other one with a blue color. Okay, so according to this theorem, any angle which is in a semicircle, angle in a semicircle, angle in a semicircle is a right angle. So semicircle diameter means straight line measurement is 180 degree, and we know that angle, inscribed angle is half of the central angle. So half of 180 degree. So if you cancel this, so this angle will be 90 degree. Okay, angle in a semicircle is always right angle, and this is true for all the points. Let me say this is point P. If I take another point, that is P dash, so this angle, okay, this angle will also be 90 degree. This angle is also going to be 90 degree. Even if I take this point P double dash, here also angle is going to be what, 90 degree. So angle inscribed in a semicircle is a right angle. Angle inscribed in a semicircle is a right angle. I hope you are getting this. Okay, if any doubt, you can write in a comment box. If you want me to repeat anything, you can write that in a comment box. Okay, so here we are ready to start with our first sum. Okay, first sum here, and you will see most of the questions which I have selected for today. Okay, either they are previous year question, already they are asked in the examination, or they have a high probability of being asked in the examination. So all in all, this lecture is very very important, and you have to attend it properly, right? So here we go. The given figure, in the given figure, O is a center of a circle. Never ever assume point O as a center. Read your question carefully, and if it is mentioned that it is a center, then only you will consider that as a center. Otherwise, student have a tendency of assuming that O is a center. So teacher can trick you by giving a tricky question. Okay, please find out, make sure that all the informations are given. Angle AOB is equal to 110 degree. Yes, I see this angle 110 degree. Calculate angle ACO. This is what I have to calculate, angle ACO. And another angle is CAO, and another angle is CAO. These are the two angles which I have to find out, right? Just now I have seen a theorem. Okay, just now I have seen a theorem. I'll start it over here. Key measure of inscribed angle. Okay, measure of inscribed angle. Okay, inscribed angle is half which angle? Half central angle. Half central angle, right? Inscribed angle means angle on a circumcircle is which angle? Is angle ACB. Is half central angle. Which is a central angle? Central angle is that angle whose vertex is on the center. So half of angle AOB. Inscribed angle has a vertex on the circle. Inscribed and central angle has a vertex on the center, right? So I have to find out angle ACB. Okay. Other name of angle ACB is ACO. If you see ACB or ACO, they are different names of the same angle. They are different names of the same angle. Okay. So they are not different. So this is what? Half into 110. And here we have our first answer. That is angle AOC is equal to what? 55 degrees. When you divide 110 by 2, you will get 55 degrees. So here I have my first answer. That is 55 degree. Correct? Now I want angle CAO also. Look here. Can I say OA is equal to OC? Definitely yes. They are radii of same circle. Where do I write that? Where do I write that? Okay, this is first part. This is first part. Where do I write second part? No space at all. So I'll try to write it over here. Second wala part. OA is equal to what? OA is equal to OC. Reason is they are radii of same circle. Singular is radius and plural is radii. Okay. Now what? Since two sides of a triangles are equal, therefore triangle is an isosceles triangle. Which triangle is an isosceles triangle? Triangle ACO is an isosceles triangle. Write the correct spelling of isosceles, because again students tend to miss this S when they write isosceles triangle. Okay, so this angle, angle CAO, can I say this angle is equal to angle ACO? They are base angles. Okay, two sides are equal, so angles opposite to them are also equal. So if one angle is 55, other angle is also 55. So other angle is also 55 degrees. So both the parts, for first part answer is 55 degree, and for second part also answer is 55 degree. Have you understood this? Yes, already some students have given the answer. All right. If you have understood this, just give a like or just comment that you have understood it. Correct? Chalo. Yes, okay. Base angles are equal. Very good. Now see, find the value of unknown variable. Find the value of unknown variable. So here variables are what? X, Y, X, X, Y. Okay, so we have to find the value of unknown variable. That means we have to find the value of X and Y. We have to find the value of X and Y. Let us start now. Can you tell me what is value of X? Again, same theorem. Okay, again, same theorem. Measure of the central angle is twice the measure of the angle, inscribed angle, or the angle whose vertex lies on the center. Correct? So I can say that angle ADB, okay, or X, for first wala question, X is equal to half of 120 degree. So variable X is 60 degree. Please mention the reason. Please mention the reason or your marks will be deducted. What is the reason over here? So reason we are going to write key measure of inscribed angle is half measure of central angle. Okay, or don't write measure, just write central angle. Okay, I'll write some reason like this. Fine. Now look here. Second question. Okay, question number 2. What will be the answer? What will be the value of the variable? Now this angle is y. Look carefully. This angle is y, right? Now which, if this angle, angle ACB, ACB is my inscribed angle, or the angle whose vertex is on this circle, which is the central angle with respect to this. So central angle is this reflex angle. Okay, reflex angle or convex angle. So measure of the entire circle is 360 degree. Measure of the entire circle is 360 degree. That is the axiom. We already know that. So 360 minus 100. This reflex angle is 360 minus 100. So this is what? 260 degree. This is what? 260 degree. Okay, so what will be y equal to? Okay, same like this. Y is equal to half of okay, reflex angle. Reflex angle AOB, not angle AOB. Angle AOB is 100 degree. Okay, this reflex angle AOB. Angle AOB and reflex angle AOB together they are 360 degree. So if angle AOB is 100 degree, reflex of angle AOB will be 360 minus 100. So that is 260 degree. Right? And half of 260 degree is what? 130 degree. 2 into 1, 2 into 3. And 0 carry forward. So for second question, value of variable y is 130 degree. Isn't it easy? Are you finding out this easy? Yes. Some students are already giving the answer. Correct? Now let's move on to question number 3. This angle is 15. This angle is 15. We want the value of x. Now what am I going to do is I'll draw a additional radius, that is radius OB. Singular is radius, plural is radii. We have written there as a reason in the other sum. Okay, same situation here. OA is the radius, OB is also a radius. Why? Okay, and both are equal. Why both are equal? Because they are radii of same circle. So in a triangle, two sides are equal. So triangle becomes an isosceles triangle because two sides are equal. If two sides are equal, angle opposite to them are also equal. So this becomes 15 degree. Same situation here. OB is equal to OC. Radii of same circle. Two radii of same circle are equal. So triangle OBC also becomes an isosceles triangle. Two sides are equal. So angles opposite to equal sides are also equal. So this also happens to be 15 degree. That means this entire angle is 15 plus 15, which means 30 degree. Correct? Now we have to find out value of x. For question number 3, x is the central angle. X is the central angle. So that is twice, okay, twice the measure of the inscribed angle. So 2 into 30 degree. So 2 into 30 degree is 60 degree. So value of variable x in this sum is equal to 60 degree, right? This angle is 30 degree, angle ABC, inscribed angle. And we have to find out measure of the central angle. In previous two sums, situation was exactly reverse. Here central angle was given and you were needed to find out the inscribed angle. Inscribed angle was half. Here inscribed angle is 30 and we have to find out the measure of the central angle. Central angle is double the inscribed angle. So inscribed angle is 30 degree and this angle, central angle, will be 60 degree. Isn't it same? Okay. Okay. Some student got answer before I could get my answer. Right? Now we have to find out value of x. Again, can I say for this is question number 4. Can I say x is a central angle? So this is twice what? Inscribed angle. My inscribed angle is 70 degree. Okay, central angle AO. If I am writing reason, I can write it this way also. Central angle is twice inscribed angle. Okay, so x is twice of 70, therefore x is how much? Double of 70 is 140 degree. Correct? Double of 70 is what? Is 140 degree. Yes, Dishita Joshi has given correct answer and others also can type their answers. Now we have to find the value of y also. Look here, more or less like a previous question. Look here. If I again draw this radius OB, OA is equal to OB. Okay, radii of same circle. In a circle, if you draw two radii, they have equal measurements. Okay, those radii are equal. So if two sides are equal, base angles are also equal. So this angle is 30. So this angle is also 30. Entire angle is 70 degree. So this angle is going to be 40 degrees. 70 minus 30 is 40 degree. Again, OB is equal to OC. If this is 40, Y is also 40. Base angles, right? So how do I write this? For second part? What I will write is Y equal to 40 degree. And what is the reason? Reason is, okay, triangle OBC is what? Is an isosceles triangle. Okay, please make sure that you write the correct spelling of isosceles triangle. Yes, answers are coming and they are correct answers, right? Okay, fine. Let's move on to question number 5. Very easy. Can you tell me what is y equal to? Yes, I am waiting. What is y equal to? First decide why. Is it a central angle or a inscribed angle? And how can you decide that? Looking at the vertex of the angle. If vertex lies on the center, then it is a central angle. If vertex lies on the circle, then that angle is the inscribed angle. So why? Vertex of the angle lies on the circle. So this is an inscribed angle. And what about the central angle with respect to this y? So central angle. So inscribed angle is half the central angle. is half the central angle, and central angle is this angle. What is the name of this angle? Is this angle AOB? Answer is no, because this angle is 240. This angle is 240 degree, more than 180 degree, more than the measurement of the straight line. So this angle is called reflex angle. Reflex of which angle? Angle AOB. Therefore, y is what? Reflex of angle AOB is 240 degree. So half of 240 degree is what? Is 120 degree. So for question number 5, answer is 120 degree. Y is 120 degree. Isn't it? Isn't it? Okay. Why 100 degree? Some students are writing, majority of you are writing 100 degree. Why 100 degree? How you got to? Okay, some. This is quite easy. Y is half of 240 degrees. So half of 240 is 120 degree, right? You need to correct your answer. Yes. Okay, yes, yes. Students are correcting their answer. So listen carefully. Can you tell me here for question number 6? Let me use this color for question number 6. Can you tell me for question number 6 what is value of x? Isn't x okay inscribed angle, because this angle has a vertex on the circle, half the measure of the central angle, and central angle is 100 degree. Half of 100 degree is what? 50 degree. So this is my first answer. X is equal to what? 50 degree. Now what can you say about y? See here carefully. For a first time we are using theorem number 2, right? Angle x and angle y both are equal. Why both are equal? Because they are angles in same segment. In same segment. In same segment. I hope whatever I'm writing that is not going out of the screen. They are angles in same segment. So x is equal to 50 degree. Y is also equal to 50 degree. And if you don't want to use this situation, if you don't want to use this theorem, you can also do by the same method. Ki angle y is an inscribed angle because its vertex lies on the circle. Okay, it is an inscribed angle, AOB, whereas angle AOB is a central angle. So this y is again half of 100 degree. Half of 100 is 50 degree. Right? Use any method. Use any method of your choice. You can use this theorem also. Which theorem? This theorem. Okay. Or you can use, they are x and y. X and y are in same segment. Again, what is same segment? I have already explained you. I think I'm live again. There was some glitch, some internet related issue. I don't know what has happened, but I was offline for a while. Now it is now it is absolutely fine. Okay. Can we start? Let me know if you could see me. Let me know if you could hear me. Please write your comment. Can you see me? Can you hear me? Am I audible? So I think problem has been solved, isn't it? I think problem has been solved, isn't it? Yes, Mamta saying is problem solved. Can you hear me? Can you hear me? Is it fine? Can you hear me? Okay, let us continue. Let us continue. Let us move on to next question. Right? We are moving on to next question. Okay? In a given figure, this question was asked in board examination in which year? In year 2018. In year 2018. In a given figure, O is the center. And please don't worry, I'm going to share this PDF, okay, a question as well as a solution in the description box once our class is over. So please don't forget to check your description box. This PDF you will get over there. O is the center of a circle. QR is equal to OP. QR, right? This is segment QR and it is equal to OP. Where is OP? It is a radius. Okay, fine. And in turn, OP is equal to OQ. OP is equal to OQ. Right? So we have three segments. One is directly given and other we have use a property. Ki they are both are radii of same circle. Angle QRP. How can it be angle QRP? It is angle QRT. Okay, angle QRT. QRT is 20 degree. Find the value of x. Again, we have to find out the value of x. Now, what we see is that angle x is a central angle. Why it is a central angle? Because its vertex is on a center. With respect to this central angle, do we have any angle on the circle? On the circle, okay? Here some students may go wrong. Please listen to me carefully. I want your 100% attention. Whenever we talk about, okay, central angle and the inscribed angle, when you write the name, their starting point and end point is also same. Right? If I say angle TOP is the central angle, inscribed angle will be also same like that, angle TQP or angle TSP. Here it is not given. If we want, we can draw it, okay? We can construct it. But we will try to solve it without a construction. We will try to solve this without a construction. So first let us concentrate on this triangle. What is the name of this triangle? Triangle OQR. In triangle OQR, what do I see? I see there are two sides which are equal. Right? OQ is equal to OR. OQ is equal to QR. Okay, I cannot write this directly. I will have to specify it properly. So what am I writing? I will write OP is equal to OQ. OP is equal to OQ. Reason is they are radii of same circle. Then I'll use this given information कि OP is also equal to QR. This information is given to me. Where? This information is given to me. Where? In the question. So what I see, both the segments OQ and QR both are equal to OP. Right? Both are equal to OP. Therefore, I can definitely say कि in triangle. Okay, therefore in triangle, okay, in triangle OQR, OQ is equal to OR. OQ is equal to OR. How do I know this? From above two equations. Okay, when you compare these two equations, from there you get this. From above two equations, right? So this triangle becomes an isosceles triangle. So if this angle is 20, this angle is also 20 degree. Correct? This angle is also what? 20 degree. Is it going to help us to find out this angle? Let's check out. Let's see. Okay. This angle is 20, this is 20, and in this triangle, sum of the measures of all three angles is 180 degree. Correct? Is 180 degree. 20 plus 20 is 40. So 180 minus 40 degree. 180 degree minus 40 degree is what? 140 degree. So this angle is 140 degree. Am I right? Okay. This angle is 140 degree. Here it is a straight line. Here it is a straight line. So the entire angle is 180 degree. Okay. So if this is 140 degree, this will be 40 degree. 140 plus 40 is 180 degree. If you don't want to use this theorem, you can also use a theorem of exterior angle of a triangle, that is equal to sum of the two remote interior angles. Okay, so there are two reasons for this angle to be 40 degree, and if this angle is 40 degree, okay, and triangle OPQ is an isosceles triangle, so this is also 40 degree. 40 plus 40 is 80, and angle sum property of a triangle, okay, 40 plus 40 is 80, so this angle has to be 100 degrees, right? Again here we have straight angle, so all these three angles are 180 degree. X plus 100 degrees plus 20 degree is equal to 180 degree. Why? Because these three are, okay, they lie on a straight line. And measurement of a straight line is 180 degree. So what? X plus 120 degree is equal to 180 degree. Plus 120 goes to other side. It becomes minus 120 degree. So this is how much? This is 60 degree. Value of x is 60 degree, right? But there is other way also to solve this. Just let me know, have you understood this? Please write in a comment box, have you understood this? I don't know what is a problem. I cannot see any of the comment. Okay, please type some comment. Okay, is there any problem with this comment box? I could not see any comment. Okay, it's showing blank. Okay, yes, now I could see it. Fine. Are you getting it? This is question number 3. Are you getting it? This is question number 3. And it is 60 degree. Right? Can we move on to next question? Okay, I got 60 degree. Yes, sir. Yes, sir. Okay. Let's move on to next question. Okay, question number 4. Looks difficult question, but it is not. And this question was asked in the year. It was asked in which year? Okay, in the year 2016. Let's see. In a given figure, AD is a diameter. Okay, AD is a diameter. So indirectly they are saying that O is a center. Because as per the definition of a diameter always passes through the center of the circle. Diameter always passes from where? From the center of the circle. So AD is a diameter, O is a center. Okay, that information was also given, but it was not needed because as per definition, diameter always passes through center of the circle. AD is parallel to BC. So you can see these arrows pointing in a same direction, which indicates that they are parallel lines. AD is parallel to BC, and angle CBD. Angle CBD is 32 degree, and find angle OBD. Let me locate OBD. I have to find out this angle. OBD. Correct? Angle OBD. Then angle AOB. AOB. This second angle I have to find out. This one. And third, I have to find out angle BED. Angle BED. This third angle I have to find out. Correct? Let me solve this. Now, how to get this angle? Yes, very easy. Whenever two lines are parallel, alternate angles are equal. What do I mean by alternate angles? Alternate angles are those angles, okay, when you combine them, it forms a English letter Z. So if this angle is 32, this angle also 32, isn't it? Are you getting it? Are you understanding it? Let me know in the comment box. alternate angles are equal. Okay, yes sir. I'll write this. Key AD is parallel to BC. My reason is given. So alternate angles between parallel lines are equal. So which two angles are equal? One is angle ADB. How do you recognize the alternate angle? By English letter Z is equal to angle DBC, and both are, one is given as 32 degrees, so both will be 32 degrees, right? So reason will be alternate angles between parallel lines. Okay, I'm writing it in a shortcut. If you have a lot of time in the examination, okay, if you are fast, so you can write a complete statement. Otherwise, write in a shortcut as I have written this, right? So I think now I should get angle AOB, the second angle. The second angle. Let me check out whether I can get this angle, first angle first. Yes, absolutely. Consider triangle OBD. In triangle OBD, again same situation is repeated again and again. Radii of same circles. Okay, so in triangle AOB, OBD, OB is equal to OD. What is the reason? They are radii of same circle. Okay, OB is equal to OD. Let me highlight on this triangle OBD. OB is a radius, OD is also radius. So base angles are equal. This is 32, so this was 32 alternate angle. Now in isosceles triangle, these two angles are 32. So my first answer is going to be 32 degrees, right? Therefore, angle OBD is equal to which angle? Is equal to angle ODB. ODB. Why? Angles of isosceles triangle. Angles of isosceles triangle. Okay, therefore angle OBD is 32 degree. This is my first answer. This is my first answer, right? Now look at this angle AOB. Angle AOB is a central angle. Okay, angle at center. You can write reason in different ways. Angle at center is twice angle at circumference. Theorem number 1, central angle and inscribed angle. Correct. So what is the central angle? Is central angle AOB? Yes. Why it is central angle? Because vertex O lies on the center. Vertex O lies on a central. So this is what? Twice the angle at circumference. Which angle? Angle ADB. And I know angle ADB. Angle ADB is 32 degree. So twice of angle 32 degree is 64 degree. This is my second answer, 64 degree. Now what is angle BED? Where is BED? Again same. Angle BED. Okay, look at angle BED. Look at angle BED. Okay, is it an inscribed angle? Yes. Why? Because vertex lies on the circle. So this angle is half the central angle. Just now we got central angle as 64. So this angle will be 32 degree. Okay, I'll solve third part over here. Angle BED, my third angle. Angle BED. Okay, inscribed angle is half the central angle. That is angle AOB. Right, same theorem. Okay, central angle is twice, angle at center is twice the angle at circumference, or in other word, angle at circumference is half the angle at center. So half of angle AOB, did I get angle AOB as 64? Yes. So half of 64 is 32 degree. So answer for my third part is also 32 degree. So this kind of questions are asked. Look here, first part ka answer we got using isosceles triangle theorem. Second part ka answer we got using first theorem of this part, first theorem of this chapter, and that says that in a circle, angle at a center is twice the angle at a circumference. Okay, and same situation but in reverse way. We have to find out the inscribed angle or the angle at a circumference. So that is half the angle at center. Okay, so these way we got all three answers. Are you understanding it? Are you understanding it? Yes or no? Please write in a comment box. Yes or no? Okay. Let us continue to the next question. That is question number 5. Question number 5. In a given figure, two circles with center P and Q intersect at A and B. Right? Two circles. One is larger in size as compared to the other one. Okay, one is larger and other one is smaller. Larger circle has center P and smaller circle has center Q, and they intersect each other at point A and B. Q, which is the center of a smaller circle, lies on the circumcircle of a bigger circle. Angle APB is equal to 60 degree. Find angle ARB. Very interesting question. Very interesting question. We have to find angle ARB. How do we do that? How do we do that? Any idea how we are going to solve? How are we going to find angle ARB? Now look here, angle ARB. Angle ARB. Right? ARB. Vertex R lies on the circle. Vertex R lies on the circle. So this angle is the inscribed angle. Okay, that will be half of the central angle. Which is the central angle now? Which is the central angle? Concentrate only on the smaller circle. For a time being, ignore the larger circle. So central angle is angle AQB. Central angle is what? Angle AQB. So inscribed angle is half the central angle. So by some method, we first have to find out angle AQB. And once we get angle AQB, okay, we get angle AQB, then we can get the measure of angle ARB. Okay, we were concentrating on a smaller triangle. Now concentrate on a larger triangle. Very nice question this. Concentrate on a larger triangle. Okay, concentrate on a larger triangle and see what statement I am making. Okay, and try to understand that. Very important question. Very important question. Okay, angle at center. Okay, angle at center or angle at circumference. Angle at circumference. Is it half or double? Is it half or double? Angle at center. Okay, angle on circumference is inscribed angle. That is always half the angle at center. Now in bigger circle, concentrate on a bigger circle, not on a smaller circle. You can ignore a smaller circle for a time being. Okay, in a bigger circle, inscribed angle is angle AQB, isn't it? Angle on a okay, AQB, vertex is on the bigger circle. Vertex is on the bigger circle. Angle AQB is angle on a circumference if you are taking a bigger circle. But if you are considering a smaller circle, then same angle AQB is a central angle. Okay, I'll give you time. Just think about it. Look at the diagram and have a introspection. Think about it. Angle AQB with respect to the larger circle. The relation of angle AQB with the larger circle, I can say this angle is a inscribed angle. Its vertex lies on the circle. But if you are taking same angle and you are considering a smaller circle, this same angle becomes the central angle because it lies on the center of the smaller circle. Okay, take your time and understand this. Now I am considering a bigger circle. So angle at circumference, that is angle AQB, is half the angle at center. Which is the half angle at center? So this is this angle. Look here, reflex of angle. Okay, it is half. Reflex of which angle? Reflex angle APB. Are you getting it? Are you getting it? Okay, angle APB is 60 degree. It is given as 60 degree. So reflex of angle APB will be 360. Okay, reflex of angle APB will be 360 degree minus 60 degree. Isn't it? Isn't it? Okay. So angle AQB with respect to angle AQB, central angle is reflex of angle APB. Okay, reflex of angle is what? Is what? 360 degree minus the angle. Okay, so half of 360 minus 60 is 300 degree. So this angle is 150 degree. Right? Now come to a smaller circle. Okay, come to a smaller circle. In a smaller circle. In smaller circle. Right? Now, if you look at the smaller circle, angle AQB is a central angle. Angle AQB is a central angle. That is twice. Okay, no, I have to find out angle ARB. So I'll write a same statement with reference to ARB. Angle ARB, I have to find out what? I have to find out angle ARB. I am about to get my angle ARB. Angle ARB is what? ARB is the angle which lies on the smaller circle, lies on the circumference. Okay, so this is inscribed angle. So inscribed angle is half the measure of the central angle. For a smaller circle, central angle is this angle, angle AQB. Angle AQB. So half. Reason is same. Okay. Angle at center is what? Angle at center. Angle at circumference is half angle at the center. So half into 150 degree. So my final answer, okay, angle ARB is how much? Is 75 degree. Have this habit of blocking your answer at the end. That makes your answer eye catching. When teachers are correcting a bundle of 100 paper, 200 papers, 300 papers, so that is a very taxing task for them. Okay, so this makes their job easy to correct a paper and to give you marks. So please help your teachers to give you good marks, okay, by blocking your answer. Fine. Are you getting it? Are you getting it? Let me know. Write your comments in the comment box. All those who are attending this class online, please write your answer in a comment box. Chalo, I am waiting. Write your answer in a comment box. Okay, yes. Fine. Okay. Okay. So Ardip is saying that this same question was asked in his prelim paper, okay, preliminary paper, that is board examination or pre-board exams, okay. So if you want, you can rewind this video later on and you can see the solution. Very important question. All the questions are important. Either they are previous year questions or this kind of question. Okay, this will give you a good practice of solving these questions. Given that O is a center of a circle, O is a center of a circle. AEC is equal to 50 degree. Right? Find angle AOB. Okay, find this angle, central angle, angle AOB. Hence show that BO equal to C. Okay, some student says that, some teacher says that proof will not be asked in the examination. So it is never given in a circular by council or in a reduced syllabus that proofs will not be asked. Proof will not be asked. Okay, so be prepared. It can be asked. Okay. Anyway, this is not a big deal. Ki BO and CE, if they are parallel, then alternate angles are equal. Okay. So this is a kind of hint. This proof is like a hint for us. It is help for us. Ki this angle has to be, this should be 50 degree. If these two angles, both corresponding angles between two lines, if they are equal, then only lines are parallel. Then only lines are parallel. Okay, that means we have to find out angle AOB, and I already know from this clue, I know that this angle is also 50 degree. Okay, let us check. Is that 50? Okay, can you tell me how we are going to solve this? Is this information given? It is given in the diagram ki AB is equal to BC. AB is equal to BC. Okay, AB is equal to BC. Right? AB is equal to BC. Yes, very easy. It's easy. BO parallel to C. Okay. Come on. Are you getting it? Are you getting it? Okay, let's see how to solve this. So this is a semicircle. This is a semicircle. But if you consider this like an entire circle, if you want, you can consider it like an entire circle. If you don't want, leave it. Right? We have a theorem, correct? Now we have a theorem that angle at a center is twice the angle at a circumference. Okay. Okay. So what? So what? Okay. What am I doing is I'm taking this construction. If you don't want, don't draw this. Okay, I'm taking this construction, right? And I will use a same theorem. And I'm going to use a same theorem. Look here. Angle at a center. Is it twice or half? Chalo. Is it twice or half? Angle at a circumference. Twice or half. What should I write here? 2 or half? Type in a comment box. Type in a comment box. 2 or half. What should I write? Angle at a center is what? Twice or half? Angle at a circumference. What? Yes, I'm waiting for your reply. Is it twice or is it half? Are you there? Are you all there? Angle at a center is definitely twice. Angle at a center is definitely twice the angle at a circumference. Okay? So with respect to these 2 points, whenever you use this theorem, please make sure that two angles, both the angles, angle at center and angle at circumference should have same starting and end point. Okay, this angle is, this relation is not, will not hold for these two angles. Okay, angle at center is which angle? Angle AOC. Okay, AOC. Okay, what endpoints are A and C. These angles should also have same endpoint A and C. But which is the angle on a circumference? ABC. Please make note of this. Okay, their starting point and endpoints are same. This same relation is not applicable for angle AOB and angle ABC, because for AOB, okay, start AOB, their letters at the extreme points are A and B, and for this angle it is A and C. Okay, so always remember ki starting ka letter and last letter has to be same if you want to use this relation, right? Therefore angle AOC is how much? Angle AOC is how much? Twice of angle ABC. ABC is given as a 50 degree. Therefore angle AOC is 100 degrees. Anyway, this is not my final answer. Now final answer is coming up here, right? So these two congruent chords, this theorem we have studied in your 9th standard. Okay, let me write the theorem. Okay, tell me whether you remember this theorem. Ki congruent, okay, equal chords, okay, equal chords subtend means they form subtend equal angles at center. Equal angles at center. Do you remember this theorem from 9th standard? Do you remember this theorem from 9th standard? Yes or no? Yes or no? This theorem was there in 9th standard. Okay, there is some problem with my comment. I'm getting very late. Okay. So these two angles are equal. Which two angles? Chords are equal. AB is equal to BC. Given chord AB is equal to chord BC. Okay, how do I know this? This is given. And I have learned my theorem from 9th standard. Okay, this angle. Okay, angle at center is angle AOB. And here, angle at center is angle BOC. Both are equal. Both are equal means what? This entire angle is divided into two parts. Both are equal. Two chords are equal, so their central angles are also equal. That means angle AOC is divided into half. Okay, two equal parts. So this is half of what? Angle AOC. And just now angle AOC I got. Okay, I got as what? I have to find out angle AOB. So this is half of angle AOC. And AOC is what? 100 degree. So angle AOB, as we have predicted, angle AOB, okay, is what? 50 degrees. Half of 100 is 50 degree. Okay, this angle is 50 degree. Let me write this properly. This is A. Okay, So as we have predicted here, कि this alternate angles are equal. This angle is 50 degree. Okay, and this angle is 50 degree. Angle AOB is equal to angle ABC. Okay, and both are equal to 50 degree. Therefore, BO is parallel to CE. Reason is since corresponding angles are equal. Okay, corresponding angles are equal. When corresponding angles are equal, lines are parallel. Okay, if corresponding angles are equal, okay, so these two are lines and diameter is a transversal. Corresponding angles are equal, so lines are parallel. I hope you know the concept of the parallel lines, right? Let us move on to next question. That is question number 7. We have question number 8 also. Okay, last two questions, right? In a given figure, C and D, A, B, C, D, okay, are 4 points on a circle. Do you know what are the points which lie on a same circle are called? Okay, they are called concyclic points. Okay, A, B, C, D lies on same circle. A, B, C, D lies on same circle. So they are concyclic point. These are terms. We never read a textbook. We never read what are these points called. What is the common name given? Okay, so for your kind information, they are called concyclic points. AC and BD. AC is a chord, BD is also a chord, intersect each other at point E, and angle BEC is equal to 130 degree. Look at angle BEC. It looks like a trap. Neither it is a central angle nor it is inscribed angle, because vertex E neither lies on a center nor on the circle. So be very careful. There is a trap. Okay, this angle is 120 degree. Angle ECD is equal to, sorry, angle BC is 130 degree, angle ECD is equal to 20 degree, and we have to find what? Which angle? Angle BAC. Angle BAC. This is quite easy. Okay, is BC diameter? Tell me yes or no. Is BD diameter 38XD? Taran Revade. Okay, thank you so much, sir. Yes, thank you, Taran. Right, is it a diameter? So answer is no, it is not given in a BC is not given as a diameter, so we are not going to do this mistake of considering BC as a diameter. Maybe, I don't know, maybe center lies somewhere here or anywhere else, so it is not a diameter. Okay, so don't take that diameter, your entire solution will be ruined. Okay, because BC is a diameter, then angle this will directly be 90 degree, which is, okay, BC is not given as a diameter. Okay, so we have to solve this entire sum. Right? Right. Are you getting it? Are you getting it? Are you close to your answer? I think I am close to my answer. Look here. Look here. Look here. Look carefully. What can you say about angle DEC? Okay, this angle and this angle. Okay, when you combine this, they are angles which are in a linear pair. They form a straight line. Which angle? Angle BEC and angle DEC. So their sum is equal to 180 degree. If this angle is 30 degree, this angle will be 50 degree. Correct? This angle will be 50 degree. Now what you are going to do, you are going to concentrate on this triangle. Which triangle? Triangle DEC. Triangle DEC. Okay, in triangle DEC, when you add all three angles, that is angle D, angle E, and angle C, sum is equal to 180 degree. Sum is equal to 180 degree. So can you tell me how much is angle D? Can you tell me how much is angle D? This angle D plus 50 plus 20 is equal to 180 degree. Can you tell me how much is angle D? Yes, I will wait. Tell me how much is angle D. 50 plus 20 is 70, and all three angles are 180 degree. Okay, let me write here. I'll write it here and solve. In triangle, okay, in triangle DEC, in triangle DEC, okay, angle D plus 50 degree plus 20 degree is equal to 180 degree. What is the reason? Okay, This is angle sum property of a triangle. Angle sum property of a triangle. Angle sum property of a triangle. Okay, angle sum property. Okay, some student already have given the answer. So if I write a complete name of angle D, so that, okay, or let me write D only, plus 70 is equal to 180 degree. Right, so angle D is equal to 180 degree minus 70 degree. Therefore, angle BDC is equal to 110 degree. Yes, students, some of them already have given. Mamta Singh 110 degree. So Parth Gaming 110 degree. Atif 110 degree. Arav. Okay, Dishita Joshi 110 degree. Yes, very good. Now what? Okay, do you know theorem number 2? Okay, according to that theorem, okay, angles in a same segments are equal. Look at this segment, okay, minor segment. There are two angles which are in the same segment. Angle BAD is equal to what? Angle BDC. BDC. Okay, angle BAC. Always remember, starting ka letter and last ka letter are same. Angle BAC, angle BDC. Angle BAC and angle BDC, they are equal. Why? Angles in same segment, minor segment. Okay, I have shaded the segment. In the initial, when I started this part, okay, in my introduction part, I have mentioned this. Okay, I have explained this. If you are not, if you have just joined now, you can rewind the video, and in the, okay, once my live streaming is over, you can go back at the beginning and you can see this, okay, this explanation. So angle BDC is 110. So my angle BAC is also 110. And this is my answer. Are you getting same answer? Am I successful in convincing you? Right? Are you getting same answer? Yes? Are you getting same answer? Okay, let us continue now. Let us continue now. Yes, yes. Dishita Joshi, yes. KV, yes. Fine. So here come. Okay, this will be our last question of the day. This will be the last question of the day. Okay. So here we go. So here we go. In a given figure, angle BAD, angle bad. Okay, BAD is equal to 65 degree, no problem. Angle ABD is equal to 70 degree, very good. Angle BDC is 45 degree, absolutely fine. Show that, proof. Angle AC is a diameter, okay. So if angle subtended by this diameter is 90 degree, okay, then this angle subtended by this AC is 90 degree, then it will be a diameter. And we have to find this angle, angle ACB. Angle ACB, this angle I have to find out. I am interested in finding out this angle, correct? So how to do this? How to do this? How to do this? Okay, okay, fine. 65, 70. So that angle is 70. Okay, very good. Okay. Now look here. First we will concentrate. First we will concentrate on this triangle. First we will concentrate on this triangle. Which triangle? Triangle ABD. In triangle ABD, angle A. In triangle ABD, angle A is equal to 65 degree. Okay, angle BAD is 65 degree. And angle ABD is 70 degree. So can we find third angle? How much is the third angle? Tell me in the comment box. In triangle ABD, we already have used this theorem, right? Angle A plus angle B plus angle D is equal to 180 degree. Why? Angle sum property of a triangle. Angle sum property of a triangle. Angle sum property of a triangle. Okay, angle A is 65 degree. Angle B is 70 degree. So yes, I can get angle D. 60 plus 75 is how much? 135 degree. Plus angle D is equal to 180 degree. Therefore, angle D is how much? 180 degree minus 135 degree is how much? Angle D, if I write a complete name of angle D, it is angle ADB. ADB, how much? Is it 45 degree? Is it 45 degree? Yes, it is 45 degree. Isn't it 45 degree? Yes. Dishita Joshi already gave the answer 45 degree, right? Now this is 45 degree. Now look here. Now look here. Be very, very attentive. We are going to concentrate on this angle now. The blue colored angle now. How much is this angle? Is it 45 plus 45 means 90 degree wala angle? 90 degree means what? This is a semicircle. Okay, 90 degree means what? Angle in a semicircle is a right angle. That was also a theorem which we have studied. So it is a semicircle. So AC is a diameter. Semicircle, only semicircle. Okay, only diameter can divide circle into two semicircles. Okay, and angle in a semicircle is a right angle. Okay, so that is what I'm going to use. So I got this as 45 degree. Angle ADC is how much? 45 degree plus 45 degree, which is equal to 90 degree. Okay, angle in a semicircle, is right angle. We have studied this in the introduction part. Is right angle. So angle ADC is a right angle. So which is my semicircle? I can say that therefore ADC is a semicircle. Do you want me to show semicircle? I'll highlight this part. Okay, I'll highlight the semicircle. Okay, angle in a semicircle is a right angle inside a semicircle is a right angle. Okay, so blue angle is inside the semicircle, so it is a right angle. ADC is a semicircle, therefore now I can definitely say that, okay, which is my diameter? AC is a diameter. Okay, because AC divide a circle into two semicircle, therefore AC is a diameter, right? Even if this proof is not asked in the examination, just go through it. Okay, that is only going to add to your knowledge. Now find angle ACB. This is quite easy now. Okay, can you tell me what is what is angle ACB, or which theorem am I going to use to find this angle? See here, angle, I have to find out angle ACB. Angle ACB, starting का letter is A and end का letter is B. Angle ACB. Okay, ACB. Look for another angle जिसका starting का letter A and end का letter B होगा. Okay, they are angles in same segment. We know that angles in same segment are equal. Can you tell me? Okay, can you tell me which is that segment? Okay, which is that segment? Okay, let me show that segment. Okay, I'll use the other color. Okay, I'll try to show this segment AB. Okay, so this major segment, okay, major segment AB. So which are these two angles which are equal? Which are those two angles? So angle ACB and angle ADB. Okay, whenever you write angles in a same segment, उसका स्टार्टिंग का और एंड का लेटर सेम होना चाहिए, both the angles. So angle ACB and angle ADB. Okay, therefore what I have to find out? Angle ACB. Angle ACB is 45 degree because angle ADB is also 45 degree. Okay, so angle ACB is 45 degree. Okay, already some of the students have given the answer. Okay, Dishita Joshi 45 degrees, KB 45 degrees, Arav Goshi 45 degrees, Soparts Gaming 45 degree, I am me 45 degree. Okay, again Dishita Joshi 45 degree. Okay, So this is 45 degree. I think this was the last sum. Okay, it is already what? Okay, so tomorrow or maybe next class when I take, I will solve a sum. Okay, and I will consider this theorem, that is the cyclic properties of a circle. Now remember, geometry is the part where most of the students lose their marks. They find geometry difficult. And if you see your question paper, already you must have written at least two pre-board examination, and we are just 10 days away from your actual board examination. So please don't ignore these questions. They are really very easy. But one word of caution, and that is that don't start solving these sums until unless you are thorough with the theorems. Okay, I already told you that I have videos based upon these theorems. Okay, what you need to do is you need to go to my YouTube channel. Okay, and in that channel you will go to my playlist. Okay, so this is my YouTube channel. You have to go to playlist, and you will go where? Maths. Okay, you will go to, okay, and in this maths you will see that I have covered all theorems in great detail. All six videos, they are gem. They will be really very helpful. Okay, this is video number 1. Okay, where I have spoken about first three theorems. Then this is video number 2. Then this is third video. This is fourth. This is fifth. And this is sixth. Please make sure that you know these theorems properly. There are how many? There are totally 11 theorems. There are totally 11 theorems. Also, I have one video based upon sure short questions. Okay, sure short questions. I have one more video on circle, that is sure short question. Where do I get that? Where do I get that? Okay, this one. Okay, this is the 7th video. Okay, here I have taken sure short questions. Sure short questions. Okay, it is related to two chords and tangent. So this is also a very nice video, and you will get one question surely, one definite question, one sure short question from this video. One sure short question from this video, right? So please make sure that you watch this sure short question related to circles. Okay, so these are 7 videos, and today's video is the 8th one, which covers, okay, which covers your syllabus of a which covers your circle. Okay, I hope you are finding out this video helpful. Okay, yes sir, thank you very much sir. Sir, you had said that it is a starting of the in the starting of the video. Yes, I have already told you this in the beginning of my class, but some student might have joined late, so I am repeating this for those students. Right? Go through this video. You will see that we have covered everything in great detail. Okay, geometry will become easy for you. It will help you to score very good marks. Okay, do you want to ask anything? I watch. I okay. Some student have already. Arav Ghoshi is saying that she already have watched this video, right? So thank you very much. Okay, if you have to ask anything, you can ask me now. Otherwise, I am ending this live stream. Okay, can I say goodbye to all of you? Okay, no doubt. Already watched. Thank you, sir. So here I am ending this class. So revise this video. I'll post this question bank in the description box. You can download that. Right? So here I am ending my stream. Right? So see you in some other class. Bye.